These are the chemicals used to perform the Bradford assay. We have the dye, equilibration and Z buffer, demi-water and BSA. A solution of 1 mg per milliliter of BSA is made using also demi-water. And after the solution was made, we use a rotator to make sure the BSA dissolved in demi-water. And then we started making all our dilutions. As you can see, we made 1.0, 0.8, 0.6, 0.4, 0.2 and 0.1 mg per milliliter. We then diluted the Bradford reagent 5 times using 4 ml of Bradford reagent in 16 ml of demi-water. And this is the color that the Bradford dilution should have after the dilution is made. Make sure to mix it. It's important that all the chemicals used in the experiment are kept at the right temperature in the fridge and not at room temperature. We then started pipetting 5 microliter of our sample in the 96 well plate. And afterwards, we put 250 microliter of the diluted Bradford reagent in the wells. To do so, it's easier to use a multi-channel pipette. When the Bradford dye binds to protein, especially to arginine residues, it shifts to its blue form, and that absorbs at 595 nanometer. And that is why we will then measure at 595 nanometers. You can already see that some wells are turning blue, some more than others. This is how our plate looked like at the end. The first row is the calibration curve. We work in duplicates for all of our samples, and the other wells are all our samples except the last one, which is blank, equilibration buffer and Z buffer. As you can tell already, in the wells where we put our sample, we can already say that there is no much protein in our samples, since the color didn't turn as blue as, for example, the calibration curve. And we finally measured the absorbance at 595 nanometers. Using the absorbance values of the calibration curve, it's possible to build a calibration curve indeed, and then from the equation obtained from the calibration curve, we can calculate the concentration of protein in all our wells based, of course, on their absorbance.